everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equation with variable equation. So we are going to solve the given differential equation of second order, and we are going to use reduction of order method to solve the given differential equation. So let's get going. Problem. Solve x plus 2 into y double dash minus of 4x plus 9 into y dash plus 3x plus 7 into y equal to 0. So here we are given a differential equation with variable equations, and also the equation is of order 2. Given differential equation. X plus 2 into y double dash minus of 4x plus 9 into y dash plus 3x plus 7 into y equal to 0. Now let's make the quotient of y double dash to unity. For that purpose, we'll divide the whole equation with x plus 2, or we can split the equation in LHS equals to RHS form, and then we can multiply both sides of the equation with 1 by x plus 2, or divide both sides of the equation with x plus 2. Okay? But I'm going to write directly. Y double dash minus of 4x plus 9 by x plus 2 into y dash plus 3x plus 7 by x plus 2 into y equal to 0. Right? Consider it as equation number 1. Now compare 1 with standard form of second order linear differential equation. Y double dash plus py dash plus qy equal to 0. Just by comparing these two, we have p equal to minus of 4x plus 9 by x plus 2, q equal to 3x plus 7 by x plus 2, and r equal to 0. Now we need to find the part of complementary function of our given solution, of our given equation using inspection method. Okay. Now just observe P and Q. In the denominator of P and Q, we are having x plus 2, right? And also we can write P as minus 4x minus 9 by x plus 2. See here in the numerator of P, we are having minus 4x minus 9. But in Q, we are having 3x plus 7, right? So here, if we get 1x plus 1 and plus 2, in the numerator we'll get 4x plus 9, right? So I'm going to try 1 plus p plus q. Okay, this gives 1 minus or plus of, it's okay, right, minus of 4x plus 9 by x plus 2 plus q 3x by 7 by x plus 2. Right, now take the LCM. We'll get x plus 2 minus of 4x plus 9 plus 3x plus 7, which is equals to x plus 2 minus 4x minus into plus minus 9 plus 3x plus 7 by x plus 2. Right? See, we got x plus 2 here in the numerator. Right? This x and 3x becomes 4x. 2 plus 7 becomes 9, right? We'll get x plus 3x 4x plus 2 plus 7 plus 9 minus 4x minus 9 by x plus 2. Right? Plus 4x minus 4x gets cancelled, 9 minus 9 gets cancelled, and we'll get 0 by x plus 1, which is 0. Right? Therefore, 1 plus p plus q equal to 0. We know that since if 1 plus P plus Q equal to 0, then y equal to e power x is the part of CF of 1, right? Therefore, y equal to e power x is the part of CF of 1, where u equal to e power x. Since we are having u, we can find derivative of u with respect to x. If u is e power x, derivative of u with respect to x is also e power x, right? Just differentiate on both sides with respect to x. We'll get derivative of u with respect to x equals to derivative of derivative of e power x with respect to x is e power x, right? Let y equal to uv be the general solution of 1. See, we are having u, which is e power x, but we need to find v, right? Then v is given by d square v by dx square plus p plus 2 by u into du by dx into dv by dx equal to r by u. Consider as equation number 2. Now substitute p, u, du by dx, r and u in equation 2. From then the equation 2 reduces to an equation in capital V, and from this capital V, or we'll get capital V also. From capital V we'll find small v. This equation becomes d square v by dx square plus p minus of 4x plus 9 by x plus 2 plus 2 by u into derivative of u with respect to x is e power x into dv by dx equal to r by u, right? Here e power x gets cancelled and we'll get d square v by dx square plus minus 4x minus 9 by x plus 2 plus 2 into dv by dx equal to 0. The above equation becomes d square v by dx square plus, now take the LCM of the two terms, we'll get x plus 2 as our LCM, and in the numerator we'll get minus 4x minus 9 plus 2 times x plus 2 into dv by dx equal to 0, right? From this we'll get d square v by dx square plus minus 4x minus 9 plus 2x plus 2 2s are 4 by x plus 2 into dv by dx equal to 0. Then d square v by dx square plus minus 4x plus 2x is minus 2x, minus 9 plus 4 is minus 5 by x plus 2 into dv by dx equal to 0. Let dv by dx, d small v by dx equals to capital V, then d square small v by dx square will be d capital V by dx. This equation becomes dv by dx plus 2x minus 5 by x plus 2 into v equal to 0, right? Now we need to separate the variables. I'll just take this term to RHS. I'll get dv by dx equals to minus of minus 2x minus 5 by x plus 2 into v. Now I'll bring this v to LHS and I'll take this differential dx to RHS. I'll get 1 by v into dv equal to 2x plus 5 by x plus 2. I'll just multiply these two terms with minus and I'll take the differential dx to RHS. Okay. So if you notice, here the variables are separable, right? We can perform integration, but okay, let's perform integration. Integral 1 by v dv equal to integral 2x plus 5 function of x into dx. So we are having integrand 2x plus 5 by x plus 2. The degree of numerator is 1 and also the degree of the denominator is 1, right? Degree of numerator is equals to degree of denominator, which is nothing but this fraction is an improper fraction. We'll make it to fraction, a proper fraction, just by writing the numerator in terms of x plus 2. Okay? I'll write the numerator in terms of x plus 2. For that purpose, I'll write 2x as 2 into x and I'll split this 5 as 4 plus 1, so that in the next step, I'll take 2 common from these two terms. Okay, see, 2 into x, 2x, plus 2 2s are 4, plus 1. Now we can write, now we wrote the numerator in terms of x plus 2, right? Since we are having 2 terms in the numerator and 1 term in the denominator, so we can split this into 2 terms. We'll get 2 times x plus 2 by x plus 2 plus 1 by x plus 2, right? Here x plus 2 gets cancelled and this becomes 2 plus 1 by x plus 2, which is a proper fraction, right? So you can write this improper fraction into proper fraction in this method, or let the denominator be t. Okay. Now I'll split the numerator 2x as x plus x and I'll split this 5 as 2 plus 2 plus 1 and the denominator remains the same. Again, now I'll write x plus 2 as one term plus x plus 2 another term plus 1. Totally we have 3 terms in the numerator, right? Now put x plus 2 equals to t, we'll get t plus 1 by t, right? T plus t 2t plus 1 by t. So we are having 2 terms in the numerator and 1 term in the denominator, so we can split the total fraction into 2 fractions. We'll get 2t by t plus 1 by t. Here t gets cancelled, we'll get 2 plus 1 by t. Now just replace t by x plus 2, we'll get 2 plus 1 by x plus 2. You'll get the same thing. Okay. Since 2x plus 5 by x plus 2 can be written as 2 plus 1 by x plus 2, then this integral becomes integral 1 by v dv equal to integral. Now replace the integrand with 2 plus 1 by x plus 2 into dx. Then integral 1 by v dv equal to integral 2 integral dx plus integral 1 by x plus 2 into dx. Now we can perform integration. This becomes log mod v equal to 2x plus log mod x plus 2 plus integral constant, say c3. Okay, for my convenience I am writing integral constant as c3. You can write log mod v as log v equal to 2x plus log x plus 2. Already we are having 2 terms in terms of log, so we'll write the constant in terms of log. We'll get log c3. Since we know that log a plus log b is log ab, then we can write log x plus 2 plus log c3 as log c3 into x plus 2, right? Now I'll take this term to LHS, then I'll get log V minus log C3 into x plus 2 equal to 2x. Since we know that log A minus log B equal to log A by B, so we'll write the LHS part as log V by C3 into x plus 2 equal to 2x. Then V by C3 into x plus 2 equal to e power 2x, right? Then V equal to e power 2x into C3 into x plus 2. Now replace this capital V with d small v by dx. We'll get d small v by dx, or dv by dx equals to e power 2x into C3 into x plus 2, right? Then dv equal to C3 into x into e power 2x plus 2 into e power 2x into dx. We'll just separate the variables, okay? Then dv equal to C3 into x e power 2x into dx plus 2c3 into e power 2x dx. Now the variables are separable, so we can perform integration. We'll find small v, okay? Integral dv equal to C3 integral x e power 2x dx plus 2c3 integral e power 2x dx. Let's find integral x e power 2x dx using integration by parts. Here we are having integrand of product of polynomial function and exponential function, right? We'll take polynomial function as u and the remaining part as dv. Let u equal to x and dv equal to e power 2x dx. Here we are going to use the formula integral u dv, which is equals to uv minus integral v du. Okay? Find derivative of u. Differentiate on both sides. With respect to x, we'll get du by dx equal to derivative of x with respect to x is 1, right? From this, we'll get du equal to dx. Now integrate on both sides to find v. We'll get v equal to e power 2x by 2. Now coming to the formula, integral u dv, u into dv equal to uv x into e power 2x by 2 minus integral v into du, which is equals to dx. This is x, okay? Which is equals to x e power 2x by 2 minus 1 by 2 into integral e power 2x dx is e power 2x by 2, which is equals to x e power 2x by 2 minus 1 by 4 into e power 2x. Since integral x e power 2x dx equal to x e power 2x by 2 minus 1 by 4 into e power 2x and integral e power 2x dx is e power 2x by 2, then this becomes v equal to c3 into integral x e power 2x dx is x e power 2x by 2 minus e power 2x by 4 plus 2c3 into integral e power 2x dx is e power 2x by 2. Here 2 gets cancelled, right? Plus integral constant, say c2. Okay? Then v equal to 1 by 2 c3 into x e power 2x minus c3 into 1 by 4 into e power 2x plus c3 into e power 2x plus c2. This becomes 1 by 2 into C3 into x e power 2x. See, these are the two terms involving C3 and e power 2x, right? So let's take C3 e power 2x common from these two terms. Okay, then I'll get 1 minus 1 by 4 plus C2, which is equals to 1 by 2 into C3 x e power 2x plus C3 e power 2x into 4 minus 1 by 4 plus C2, which is equals to 1 by 2, or better C3 by 2 into x e power 2x plus C3 into e power 2x into 4 minus 1 3 by 4 plus C2. Now I'll take C3 and e power 2x common from these two terms. I'll get C3 into x by 2 plus 3 by 4 into e power 2x plus C2. This becomes v equal to C3 into, take the LCM of 2 and 4. 4 is the LCM. In the numerator, we'll get 2x. See, in the denominator of first term, we are having 2, so close to, and multiply this to 2x, you'll get 2x in the numerator plus, in the denominator of second term, we are having 4. 2 2s are 4, so we need, so there's nothing to multiply with 3, just write 3 as it is into e power 2x plus C2. Then v equal to C3 into, you can split this as 2x plus 3 by 4 plus e power 2x plus C2, right? Then v equal to C3 by 4 into 2x plus 3 plus e power 2x plus C2. This is not plus, it's into, okay? So we got v and already we are having u, so let's write the general solution. Therefore, the general solution is given by y equal to u into v, which is equals to u e power x into v is C3 by 4 into 2x plus 3 into e power 2x plus C2, which is equals to C3 by 4 into 2x plus 3 into e power 2x into e power x plus C2 e power x. Then y equal to C3 by 4 into 2x plus 3 into e power 2x into e power x is e power 2x plus x. Just add the powers. We'll get 2x plus x is 3x plus C2 e power x. Now let C3 by 4, since C3 is constant and 1 by 4 is also constant, we can write this constant or name it as C1. Okay, we'll get C1 into 2x plus 3 into e power 3x plus C2 e power x, which is the required solution. This is the right. See, to write C1 in the final answer, I have picked the first constant, first integral constant as C3. Okay, so that it looks good finally, right? C1, constant C1 and C2 appears in the solution. So we have seen a problem from reduction of order in this video. Hope you'll understand. We'll see you in the next video. Till then, bye bye.